Hello and welcome to video number 2. So last time what we did was we got ourselves up and running with a basic Aqueduct project. So what that looks like is we used the scaffolding tool to generate this list of files and folders, and then we created some routes in libchannel.dart. We created these two routes in particular. Looking at this example that was generated from the scaffolding tool. So we created a route at the root path, and we returned the text hello world, setting the content type to HTML, and then we created this client route, which is responsible for returning this client.html file, which in turn was generated using Aqueduct's Swagger UI generation tool. So the command is Aqueduct document client, which we use to generate this file. And then this file is what is giving us this Swagger UI interface, which initially I said we would use to test our REST endpoints. But instead of using this, I think it'd be better to use Postman in the meantime, because using this Swagger, well, we would have to regenerate this file each time we make a change to our endpoints. So just to speed things up, I'm going to close this, and then I'm going to use Postman. Yeah, so I got it prepared for us. So our server is running still, so I should be able to come here and still get hello world as a response. Okay, so in this part in particular, what we're going to be doing is we're going to be looking at routing in further detail, and specifically we're going to create an endpoint that will have the capabilities of performing CRUD type operations, so create, read, update, delete operations on a data set. So yeah, let's begin. Right, so I'll start by creating a new endpoint called, in fact, I'm not going to create a new endpoint. I'm going to replace this example endpoint with reads, and then I'll leave the link function, which takes in a closure which exposes the request object. So in fact, what I can do is just to give an idea of what it will look like, I will do a switch based on the request method, and then I can check the case for get request, and if it's a get, I'll return the response hello world. So it's similar to what we had earlier on. And then for default, I'll just return an OK for now. Okay, so let me kill the server, restart, give it some time, and then if I hit send, that reads, we get hello world, and if I try something else like a post, it returns some other method as expected. We can handle the request method in the link function. So if I speed up and show you effectively what it will look like. And then with the default, we will send a response object where our HTTP status would be method not allowed, and we need to specify two other arguments. So we need to specify a map. It takes in a map representing our headers and a dynamic body. So for our headers, I'll just set it to null, and for our body, I'll just say method is not allowed. So let's save this, and then let's restart the server, and then let's try this again. So if we try with the get, we get all reads. If we try with post, we get created a read. If we try with put, updated a read. If you try with patch, it should say method is not allowed. And then if you try with delete, it says deleted a read. So that works well for us. So although the logic we have here works for us, I guess in a simple case, problem is that the more logic we add in this link function, the more difficult it gets to maintain. So as recommended in the Aqueduct documentation, it's recommended to use link instead of link function, and the URL is actually http:/controller. So it's recommended to create a controller to handle our requests coming in, and then we use a link function to instantiate that controller. So I'll show you how to do that right now, and in order to do that, we will create a new folder under the lib directory called controller, and then we will create a new file in controller and we'll call it reads controller. So in reads controller, we will import the Aqueduct package, that one, and then all we need to do is we subclass a class called controller. So reads controller extends controller class, so this comes with Aqueduct, and then we need to implement the handle method. So that takes in the future all request or response. The method is called handle, which gives us the request to manipulate. And also we need to import the .async class in order to use this type. So we should now be able to use the same logic in our switch, and then we'll place it in here, and we'll import the .io in order to be able to use the HTTP status, which is an abstract class. Okay, all right, so we'll annotate this with the request, and we can come back to this file. We can import our package, we'll import the controller in here, which means that we can now use the link method and then return our reads controller. So now let's restart our server and let's try this again. Okay, so I should be able to get a response when I think it's starting. Okay, started now. Okay, there we go. Done the delete, patch, methods not allowed, put, update, post, create, and so on and so forth. All right. So even though we're able to do something like this to handle our request, it still wouldn't solve the problem where the logic to put here would make this difficult to maintain in the long term, especially using a switch statement as well. So instead of using a controller, we can use what is known as a resource controller, which allows us a bit more control, creating CRUD operations on our RESTful endpoint. So using resource controller, that means we can, instead of doing this, which by the way, this will still work using a resource controller, because resource controller is an extension of the controller type. So let's, instead of doing that, we can do something along the lines of this. So we will start by creating an annotation to mark the type of request it is, and this annotation, this method would return a feature of type response, and then we'll call this getAllReads, and we need to mark it as async, and then we'll return a response.ok getAllReads. So now let's test this now, but then I will comment this out and I'll test this endpoint by stopping the server and starting again. And then if I hit send, it should return the same response. Okay, so it's working. So in a similar fashion, we can do the same for our other type of request methods. So for a post, we'll be marking it with an operation.post, which the method signature is going to return a feature of type response. Then we'll say create new read, and we mark it with async, which returns a response. Created new read. I just put a full stop here. So I'm going to speed up and create the same for our put and delete. Let's check this is working again by restarting our server. So give it a moment. And then if I hit send, we get getAllReads with post, created new read with put, updated read with delete, deleted read. And of course, for any unsupported endpoints, nothing would be returned. But then it's a it's essentially a 405, which is method not allowed. So Aqueduct does that for us behind the scenes in its controllers. Okay, so this saves us from relying on this handle method. And in fact, these handle methods are good for whenever you want to implement any form of middleware functionality. So let's say before you access these particular CRUD operations, this handle method would be invoked before you get to this part. So in here you can perform any sort of validation logic to check the user tokens or you know, anything along those lines. But in this example, I'll get rid of it. We don't need it. Let's define a data source that we can interact with through these methods. So I've got an example here of a list that takes in 3 objects representing a list of reads, or a reading list. So based on this, we can do something along the lines of, when we make a GET request, we can respond with the reading list, which we titled reads, And we'll test this out by saving and restarting our server. So while it's preparing, select get and then run it, and then yeah, there we go, gives us a list as expected. So for our post request, what we need to do is, since we'll be adding a new item to our reading list, we need a way of capturing the request body and appending the content to our list of reads. So for this example, I'm going to copy this one and I'll change this to a post request, and then the post body will take in raw JSON information, and I'll just change the title just so it's randomized a bit. 2018. And then in here, we need a way of capturing that. So I'll do final of type map, which is string, and then the value is, I'll set it to dynamic, and then body. And then what we need to do is await the request.body.decode. So that should give us a map representation of this JSON that we're sending across. And so we can do reads.add, and then we add our body to it. And once that's added, we respond with what was added to it that way. So let's test this out and see what we get. Okay, so it's preparing. Then if I hit send, we get blank back for 15. Oh, that is because we need to send our body as a JSON object. So let's try again. Yeah, there we have it. So it's successfully been added. So if I make a get request, we should see the 4th entry in there. Okay, that's perfect. So now onto our put request. Now we are using this put to make an update to a pre-existing item in our list of reads. So in order to know the particular item to update, we need to be able to pass in an index representing the position of the item that we wish to update. So to do that, what we need is a route variable, which we will define in our route. So if we come back to channel.dart, at our reads route, we will define a path variable starting with a colon and the name of the variable. So that's the first step. Second step is we'll return back to our reads controller, and in the operation.put annotation, we'll pass in an argument with the name of the path variable or the root variable we expect, and then also we can capture that in as a parameter in updated read by using another annotation called bind.path, and then we'll say we expect the ID, which gives us the ID, and then we will cast it to an integer. Yeah, so yeah, should look like this, which means now we'll be able to use the ID here by doing if you need to check that the ID is within range. So if ID is less than 0 or ID is greater than reads.length minus 1, which means that it's out of range. We return a response not found. And I believe we can say item not found. And we need to use the named parameter called body. Okay, else we can do reads ID and then replace with our request body, which we can retrieve by doing the same thing as this one here. Okay, and then I can respond with, I'll respond with the same text. So let's save this and let's try it. I'll restart the server. So if I copy this, I perform a put request, then in my body I'll make sure it's application.json, and then we'll specify that we want to change the last item in our reads. And then if I send it again, it says updated read. So if I make a get request to the reads endpoint, it gives us a 404 not found. Alright, so I figured out what the problem is. We need to go back to channel.dart and we need to make this root variable optional by using the square brackets. So that's the first thing we need to do. So if we save that, come back to this file and restart it. So doing a get request will give us all the results, and then I can do a put request to update, and of course it won't work because we need to specify the index. So I'll send that again updated read, and if I proceed to make a get request, we should get the updated item. Okay, so now it will also be a good idea to have a get request that returns a particular item, so something along the lines of this, which now if I send, it still just gives a 200 OK. So we'll define an operation .get annotation and pass in ID as an argument. It will return a feature of type response. We'll call it get read, and then using bind.path annotation, we'll extract the ID, and then so what we'll do is we'll return a response.ok, and then it will be reads and then our particular ID. But before, and let's mark this as async, and before we do that, we need to ensure that it's within range. So if ID is 0 and reads.length and ID is greater than reads.length minus 1, then we want to return a response not found. And then our body is item not found. So let's save this, restart the server, and give it a go. Okay, so do a normal call to /reads, and then let's see if we can get a second one. Perfect. And the next operation we want to look at is a delete operation. So like the put, will also pass in an ID as an argument to operation.delete, and then we will use bind.path. We'll extract the ID variable and cast it to an integer, and essentially we'll also make sure that the ID is within range. So I'll copy this logic. Else we'll just do reads.remove at index. So let's save this and give this a go. So by doing a get, we got 3 items, and if I do a delete, let's delete the last item, we got deleted read. So if we do a get to here, yeah, it should say item not found because we deleted it, which means there are now 2 items in our list. Okay, perfect. So before I sign off quickly, I've just learned that the request body is already decoded by our resource controller before this method is run. So in fact, instead of awaiting for request body decode, we can literally just do request body as, which would return the body that was already decoded prior to this method being called. So I'll do the same here, and then I'll get rid of .io, save this file, and then I'll restart the server and try one more time. Okay, so let's do a get. Okay, cool. Get reads 2. Okay, awesome. And then perform a post. Yeah, 2018 to reads, send there, perform a get. Okay, that's awesome. And then I will do a put, just add an R to it. Of course, wrong request. And then send, updated, do a get. Here's the second one with a change. There we go. And then let's delete our duplicate. Okay. Okay, perfect. So I'm going to leave it here, and in the next video we're going to refactor the body of our requests to extend a class that Aqueduct uses called HTTP serializable, which essentially wraps the structure of our model. And also we're going to look at setting up our PostgreSQL database. As always, thanks for watching this video. I hope you learned something different. If you have any feedback on the content presented, let me know in the comments below. Don't forget to like, subscribe, and hit the notification icon to be notified when new content is released. Thank you.